In this video, I want to give you an overview of the electrical engineering and the different branches of electrical engineering. So electrical engineering in general concerns systems that produce, transmit, and measure electric signals. So in this field, we basically combine the physical models of natural phenomena with mathematical tools, and we manipulate those models to produce systems that meet some practical need that we may have. So there are 5 major classes of electrical system. We have communication systems, we have computer systems, control systems, power systems, and finally signal processing systems. So communication systems are used to generate, transmit, and distribute information. You can think of a lot of examples for this branch of electrical engineering. Examples include TVs, camera transmitters and receivers, VCRs, radio telescopes, satellite systems, radar systems, and so on and so forth. So for example, to the right, you see major components of a modern telephone system. So in one end, we have the telephone system. You speak to it through the microphone. There is a wire that transfers the data to the switching center. We have some cables or coaxial cables that transmit this data to the microwave station. We use some transmission antenna. We have communication satellites, and on the receiving end, we have the receiving antenna, the microwave station again. Different types of cables possible. For example, here we use fiber optic cables, and then to the switching center, and then cable, and then to the telephone of the receiving end. So as you can see, a communication system contains many components, and this is a very basic representation of a communication system. The second class is the class of computer systems, which are used to process information that can range from word processing to mathematical computations. Computer systems usually range in size and power, and they contain microcircuits, integrated circuits that each can contain thousands, millions, or even billions of electrical components and transistors that usually operate at speeds and power levels close to the fundamental physical limits. So as for speed, if we consider the electric circuit that is being used inside the CPUs, the speed of the electric charge travels close to the speed of light. Or on the other hand, the power level is again close to the limit of the power level, because as you know, the transistors are getting smaller and smaller, right? So I think the current technology is 7 nanometer transistors. So we are very close to the limit of possible size for the transistors. So these fall all under the category of computer systems. For the third class, we have control systems, which use electric signal to regulate processes. So some examples include temperatures, pressures, and flow rates in an oil refinery, a fuel-air mixture in an automobile engine, motors, doors, lights in elevators, and so on and so forth. So all of these fall under the category of control systems. We can have power systems, which their main goal is to generate and distribute electric power. Usually power systems work with electrical energy that is generated in very large quantities. by nuclear, hydroelectric, and thermal generator. And they are distributed by a grid of conductors across the countries or the continents. Because of that, the major challenge for this type of system is to provide enough redundancy and control. So if we have some failure on any piece of the equipment, we don't cause a city or a region to be out of power completely. And finally, we have signal processing systems, which act on signals that represent information. So these type of systems transform the signals and the contained information into a more suitable form. So examples include image processing systems that are used for weather satellites. Another example is the broad class of medical imaging devices. So on the right you see some examples of the data that is generated by using these type of systems. So as you can see, between these 5 different classes, you can think of so many components that are basically shared between the two, or between several of them. So for example, if you talk about an MRI machine, magnetic resonance imaging machine, right? You need to have a power system. You probably need to have a communication system inside too, right? You need to have a signal processing system. So you would say the area or the boundary between these different classes are a little bit blurred, right? So usually complex electrical engineering systems require interaction between different engineering disciplines. So not necessarily the branches of electrical engineering, but other branches of science as well. So here you can see a commercial airplane which contains itself communication system, computer system, control system, power system, and signal processing system. So in this video, I gave you an overview of the electrical engineering in general, and we briefly went over the different classes of electrical engineering systems: communication systems, computer systems, control systems, power systems, and signal processing systems. In the upcoming videos, we will go into much more detail about electrical engineering in general and circuit analysis more specifically.